I've got a problem up here. I want you folks to try this one. This is another linear equation. The biggest power of the trig function that we have that shows up is just cosine to the first power. This one isn't quite as nice as the last one, because last time we had the trig function equals a number. This time you want to get it into that form and then solve it. Same directions as last time. Find all solutions in the interval from 0 to 2 pi, and then find all solutions. So go ahead and pause the video and give that one a shot. So the first thing I want to do is isolate that trig function. So I'm going to add that one over. So 2 cosine of x equals 1. And then I can divide both sides by 2. So cosine of x is equal to 1/2. Now, again, if you've memorized the unit circle, you might be able to just state from memory what the two angles in the interval from 0 to 2 pi are that have a cosine of 1/2. Do be careful and make sure you get both of them. Okay. I'm going to just work through it because I kind of like going through this process. So I'm going to say, let's think in terms of quadrants. This is a positive number. So I'm definitely going to have a solution in quadrant 1. Won't have a solution in quadrant 2 or 3 because cosine would be negative there, but I will have a solution in quadrant 4. So I'm going to have an x value there. And of course, since this is not an acute angle, I'll have a reference angle alpha. Now what's kind of neat is when one of my solutions is quadrant 1, that tells me that I have an acute angle that is a solution. Whatever that acute angle there is, that's going to be my reference angle for my solutions in other quadrants. Kind of nice. Okay, so there, I've used the fact that this is positive to figure out that I'm in quadrants 1 or 4. The reference angle is going to be the acute angle that has a cosine of 1/2. Again, I might know that, or I might prefer to just draw my 30, 60, 90. Cosine of 1/2, that's going to be 60 degrees or pi over 3. Okay, so here x is pi over 3. Here alpha, my reference angle, is pi over 3. And this would be then x is 2 pi minus pi over 3. That's 6 pi over 3 minus pi over 3, or 5 pi over 3. Okay. So for part A, I've got pi over 3 and 5 pi over 3. For part B, the period of cosine is 2 pi. So what's kind of nice is I can think of this as I'm just adding a multiple of the period because I know we repeat our output values over every interval of length, the period. I can also think of it as I'm getting to a coterminal angle because the period corresponds to a full revolution. So I would say pi over 3 plus 2 pi n, or 5 pi over 3 plus 2 pi n, where n is an integer. The book tends to give the answers a little bit more formally, tends to put it in set notation. So it would give this, for example, in set braces. I'm not concerned that you be that formal, but I do want to make sure that you're specifying that your variable n here is an integer. Okay, excellent.